Okay, so in this question of isometric, you can see the two views are given, front view and top view, and origin is on which side of the front view? Right side of the front view. Origin is given on right side of the front view, right? So let us calculate first maximum length, maximum height, and maximum width of this question. So maximum width, can anyone tell me the maximum width of this question? 60. See, maximum length, radius is 30 millimeters. So from this point to this point, the distance is 30. 30 plus 30, 60. 60 plus 40, 100. 100 plus 20, 120 millimeter is the maximum length. Maximum height, how much will be the maximum height? So for calculating the maximum height, how much is the diameter of this semicircle? 60. 60 plus 15, 75 is the maximum height. Then maximum width, how much is the maximum width? In top view, you will get that is equal to 60 millimeter. Is that clear? Maximum length 120, maximum width is 60, maximum height 75. So let us start drawing now. First I will draw horizontal line F8. Okay, so I will draw projection line, a bounding box we will draw first. Okay, okay, so let us draw bounding box L, enter. From this point, how much is the length? 120 millimeter. Height 75. Width is equal to 60 millimeter. 60 or 40? 60, yes. 60 millimeter. So from this point, length is 120. Height 75. F5, change the plane. Again width 60 millimeter. Height F5, change the plane. 75 millimeter. Okay. Close this and we can close this. Okay. Now this is the bounding box in which this complete object is going to be drawn. Okay, let us start now with this object. Okay, so you can see that there is a non-isometric plane. This inclined surface is not parallel to any of the isometric plane. So we will first start from the origin. When we start from the origin, how much is the height? Total distance you can see 65 and 50. So this remaining distance is how much? 15 millimeter, right? 15 millimeter, 20 plus 40, that is 60 millimeter. Okay, so I will start from this point, select outline, L, enter. From this point, vertical distance is 15 millimeter. Okay, similarly on the other side, vertical distance is 15 millimeter. Okay, then this line we can draw. Similarly from this point, F5, change the plane. This distance is 60. Vertical distance, now when we have drawn 20 plus 40, 60, vertical distance is again 65 millimeters. So this distance is 65 millimeter. Once you have taken that 65 millimeter, this horizontal distance you can see from this point. What I have done, from this point origin 60 millimeter, vertical distance 65 millimeter, and again I will come back to 20 millimeters. So 20 millimeter. Then you can connect with that inclined surface. So this is a non-isometric surface. So this portion I have drawn. Okay. Now let us complete this object. L, enter. from this point F5. Okay, this distance is 60 millimeter, 20 millimeter, and again inclined surface. L enter from this point, this edge. L enter this point, this edge. So I have drawn a bounding box for this. Okay, slot we can draw it later on. So let us leave that slot as it is. Now let us concentrate on this semicircle. So this semicircle is at a height of, you can see there is small distance, but from base it is at a distance of 15 plus 60, right? That is total 75 millimeter. So let us first draw the center line for that. Okay. So switch on the center line. L enter. From this point, select center line. L enter. From this point, right? This is the center line for reference which we have drawn. Okay. So here now this distance will be equal to, okay, 1 second. L enter. From the center, total distance is 30 millimeter. Then vertical distance F5, vertical distance 30 millimeter. Okay. So this is that center, 30 millimeter, 30 millimeter. This is the center, but it is at a distance of 30 millimeter from center line. So we have drawn this center line. Okay. So what I will do from this line, from this point, L enter, outline, L enter. This distance is 15 millimeter. Enter. Again, this distance is 15 millimeter because the total distance is 30. So from center line, this distance is 15 millimeter, 15 millimeter. So I have taken that 15 millimeter, 15 millimeter. Okay. Now let us draw ellipse, which is having, first let me copy this, copy center line, this as a base point on this side. Similarly, on the other side, you can take it a copy of that. Okay. Now I will type ellipse. Okay. Now we have to select I, enter, select this as a base point, change the plane F5. Okay. And radius will be how much? 30 millimeter. Sorry. Yes. Radius will be equal to 30 millimeter. So this is the center. Okay. And this is that point, but it is having a curvature. So at present, what I have done, we have selected this as a point, but it will not be seen as a straight line here. It will be at the top. Okay. So this point we got vertical line, same thing. L enter, F5. I will copy this, copy from this base point and change the plane F5 at a distance of 30 millimeter. Okay. Okay. This line will not be there. So leave it, delete it. Instead of that, here we will get a tangent. Okay. Then trim option, TR double enter. This curvature will not be there. Similar to this, here small curvature will not be there. This curve path will not be there. Now this is semicircle. If you observe, this is completely a semicircle. So we need to show that. L enter. From this point, I will draw vertical line F5. Okay, I will trim the lower part. And even this part I will trim. Delete. Similarly, L enter from this point. Can connect it till this point. TR double enter. Remove this. Now this you can select and delete the part. Okay, this line was a center line drawn for reference. Okay, let it be. Even this line was drawn for reference. I will select it and delete that line. Okay. Now L enter from this point. How much is the thickness, length? Let us check in top view. Okay, this distance. This is the point. From this point, the distance is 30 plus 30, 60 millimeter, right? So I will take 60 millimeter, L enter, then F5, change the plane. This distance is again 30 millimeter. From this point, again I'll close this. Okay. Now, this portion, I will delete this line, even delete this line. For instant, I will not keep that line. Okay, again I'll undo. Okay, this line is overlapping, right? This line as well as these two lines are over. So you can hide it or delete that line. Okay. Similarly, L enter. From this point, I will draw a line. Will end at this point. TR double enter. Trim this point. Okay. Now there is one more semicircle. Sorry, complete circle of radius 15 millimeter, dia 30. So that we can draw ellipse. I enter. Select this as a center. Change the plane F5. Okay. Radius 15 millimeter. Enter. Right. So this is again the circular. Now let us concentrate on this portion here, how it will merge with this. Okay. So for that, total height is 75, out of which this distance is 65. So the remaining distance, how much will be this distance? 10 millimeter, right? The total height is how much? 60 is the diameter plus 15, 75, 75 minus 65. So this distance is 10 millimeter. Okay. So that distance will be equal to 10 millimeter and it is going to merge with this. So this distance is given 20 millimeters. So that also we need to take help of that. Okay. This distance is total 60, 30. So on this side it will be 15 millimeter. On this side again it is 15 millimeter. 15 plus 15, 30, and this distance is 30 millimeter. So starting from this point, L enter. Okay. I will take F5, this line of 15 millimeter, right? Then from that point F5, I will take draw vertical line. 15 millimeter distance. You copy this line, selecting this as a base, copy it here. Okay. L enter, draw vertical line from this. Okay. Use TR double enter, trim this, trim this, trim this surface as well. Okay. Now L enter, from this point, the distance is 30 millimeter. Take that 30 millimeter and again draw vertical line. So this surface is going to merge with this inclined surface at this point. Okay, vertical line I have drawn. Then L enter, from this point, change the plane parallel to left isoplane, draw a line. Then use trim option, TR double enter, trim this edge, trim this edge. So you can imagine that, right? This is a single surface. Here it is a horizontal surface. So we have completed this part. Okay. If I hide the center lines, if I hide the projection lines, this line is not required, delete it. So this rear part we have completed. Now coming back to that slot, again I'll switch on the hidden lines, that is projection lines and center line. Coming to this slot is having thickness of 16 millimeter and height is not given. Okay, height is not given, but this distance is given as 20 millimeter. Okay, so that with the help of this 20 and this 16, let us calculate. So for that, what I will do first, I will select a center line and I will draw a center line. This triangle represents the center. So this is the center line parallel to, say, copy this as a base point. Okay, this is the center line of that object. So center line I have converted. Then we need to take that 20 millimeter distance. So everyone please concentrate here. See this 20 millimeter and then only you will get that slot. So how to get that distance? So I'll select it as a, let us consider a projection line. Okay, L enter, from this point You have to take horizontal distance 20 millimeter, then transfer it vertically. So wherever it intersect with this inclined portion, from that point, you draw a line, horizontal. This will go and intersect with this center line. Now we got that point. Okay. So convert it into, select our outline. Slot thickness is how much? Of 16 millimeters. So on one side it will be 8 millimeter, right? Similarly, L enter from the other side it will be of 8 millimeter. Escape. Okay. Then you select this line, copy, enter. Selecting this as a base point, copy it at this point, copy at both the points, and trim the extra portion. This portion you can trim it off. Okay. Now L enter, draw vertical line F5. Similarly, from this point you draw vertical line. Use trim option, TR double enter, remove the excess portion. Okay. Then you will get the edge here from this point F5. This edge will be there. TR double enter. Now you can switch off projection lines, interline, and you can observe this question. Okay. So you can see that there is a slot here of 16 millimeter width. So that slot is this. The height is not given. So that height, what we have done, we have transferred it horizontally. Then we have taken the projection. Okay. And then this slot we have created. Similarly, this lower. Switch on again the projection lines. I will take help of center line and you can start drawing. Is that clear? Okay, now you can start drawing.